Hello, today we are going to talk about graphs. So what are graphs? A graph is a picture and it is a way to show how two sets of numbers are connected. So just as an example, suppose that I measure the temperature each day from Monday to Friday. Okay, I measure the temperature at 12 o'clock noon, right? So, and I write down the value every day on my thermometer. Okay, so I'm going to call Monday the day 1, Tuesday day 2, Wednesday day 3, Thursday day 4, Friday day 5. Right, and the temperature suppose that I measure the temperature in degrees Celsius. So that's the temperature. And on Monday, the temperature at noon is, say, 25. On Tuesday, it's 21. On Wednesday, it's 16. Okay, on Thursday, it's 20, and on Friday is 23. So I write down the temperature that I measure. Now I can make a picture of this number. So this is how we do it. I draw two lines, one horizontal and one vertical. These are called the axis, and I mark out the number of the day on the horizontal axis. So 1, 2, 3, 4, 5. So that's the day. Okay, and for the temperature, I use the vertical axis, this one. I think of it like a ruler. Okay, so I can put some marks on it, like say this is 0, that may be 10, and that may be 20, that may be 30. Right. So on day 1, the temperature is 25. Now I can mark this 1 and 25, this pair of numbers, as a point on the graph. So I go to 1, that's the 1 for the day 1, 25. So I'm using the vertical scale to represent temperature. Let's call that temperature. So 25 would be in between 20 and 30, so it's somewhere there. Day 1 is there. So I'm going to, from 1, imagine going straight up along a vertical line, and from 25, imagine going horizontally, and they meet at a point. This vertical line and the horizontal line meets at a point, and I put a mark there. Right, so that mark would represent this set of numbers, 1 and 25. Okay, if I look at the mark, I know that it's directly above the number 1 for day 1. Alright, so that mark tells us that it's a mark for day 1. And if I go horizontally from the mark, I go to 25 degrees Celsius. Right, that's degrees Celsius. So the mark tells us this information. Alright, 1 and 25. So we can do the same for the next pair of numbers, 2 and 21. So that's 2, go up. 21 would be about there. So that's 20, 21 is just above 20. And I put a mark there. Right? So day 3 is 16, so we go 3 until 16 is about halfway between 10 and 20, it's just a bit higher. So that mark is 3 and 16. 4 and 20. So 4 and 20 is another mark. 5 and 23. 5, 23. So I have these marks there up to 5 points. So that's a graph. Okay. Now let me just clean off this. So we're just looking at the points now. So the point represents the graph. And if we look at this, we can actually see how the temperature changes with the day just by looking at it. You see, as you move from day 1 to day 5, you see the points go down and then come up. That means that the temperature go down and come up again. And one look at this, you know, on this day, on day 3, the temperature is lowest. So that means Wednesday is the coolest day of the week. So that's the reason for making graphs. Just by looking at it as a picture, you can quickly see some information that is more difficult to see just by looking at this number. Of course, you can look at the number one by one and you can still tell that on day 3 the temperature is smallest because the number 16 is the smallest of all the numbers. Okay, but you still have to look at the number one by one and think, right, 21 is less than 25 and 16 is less than 21, like that. But if you have a graph, you don't have to think of the numbers. You're just looking at a picture and the lowest point there is the lowest temperature. Now, and quite often, just as a way to guide the eye, we would draw points or maybe a curve through the points. Okay? So a curve like that helps us to see the way that the points change, the way that the graphs change. So we can see that it goes down and come up again. And that's helpful if we have a lot of points. Okay, and also the shape of this curve also tells us quite quickly that the temperature first goes down and then come up again. So this is the way that the picture tells us very quickly some information, okay, that is not so obvious, that we can't see so quickly just by looking at the numbers. Right, so that's a graph. Now we can think of all sorts of graphs and you see them on television or newspaper sometimes. So apart from temperatures, which you see on weather forecasts, there will also be other types of graphs. Like if you look at the financial page on the newspaper about the prices of stocks and shares. Okay, I never really understood that, but people like to see how the price of this stocks and share change with the day or with the month. So what they do is they plot a graph. Okay, now in mathematics, we are more interested in, especially in this high school or O-level mathematics, we are more interested in using graphs to represent equations. So instead of looking at temperatures that you measure day by day, we are interested in making an equation and plotting a graph for the equation. So what does that mean? Let's take a look. Okay, now we have learned some equation already. We have learned in algebra quadratic equations and also linear equations. Right, linear equation means something like that. Say y is equal to x plus 1. Now, that's a simple equation. In algebra, that we can have equations with just one symbol, x, and then we can solve for the x. But we can also have equations like that with two different symbols, and maybe even more. But here, we are just going to look at equations with two symbols. So if you have two symbols like that, that's one kind of equation. And we can plot a graph for this equation. Now this equation shows a relation between x and y. Right? We can think of this as a relation. So for example, if x is 1, then we know that 1 plus 1 is 2. That means that y is 2. So let us make a table. Okay. Let me make up some value for x. Let's say I have minus 2, minus 1, 0, 1, 2. So x have these values. Now I want to find the corresponding values of y. So substitute minus 2 into the x there. I have minus 2 plus 1, that's minus 1. So when x is minus 2, y is minus 1. Okay, so that's what this equation tells us. Now if x is minus 1, then minus 1 plus 1 is 0. So we keep going, 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3. So what you see now is a list of numbers. Okay, we call this a table of number. Right, that's the way of writing these numbers out like that. And it looks a bit like the table that I showed just now, where I have days here and temperature here. So now I just have x and y. It's just two symbols, it doesn't mean anything at the moment. It's just two sets of numbers. But what I can do is I can also plot the graph. So let's do that. So I would make two axes. Okay, show that again. So horizontal and vertical axis. Now I'll call this axis, the horizontal axis x, and the vertical axis y. Okay. Now the point where they cross, we would normally call it the origin. Origin meaning is the point of 0. So for example, if x has values from minus 2 to 2, I would mark them out like that. So minus 2, minus 1, and then the 0 is at the origin, 1 and 2. Okay, so there's a name there. I call that the origin. It's called the origin, the point of 0. and y goes from minus 1 to 3. Mark that out. Minus 1, 0, 1, 2, 3. So I have my marks there. Now, let's make the points. Like before, we have this set of numbers, minus 2, minus 1. So when x is minus 2, it's here. So we want to go along the vertical line until we come to a point where y is minus 1. So y is minus 1 is there. Okay, so the point that we should mark would be here. So this point would have minus 2 for x and minus 1 for y. So that's the point for this set of numbers. Now, in the same way, for the next pair of numbers, minus 1 and 0, we have minus 1 there for the x and 0 there. So this is a little bit tricky. So when x is minus 1, we should move along the vertical line. And when y is 0, that's the 0, we should move along the horizontal line. So the horizontal and the vertical meets here. Okay, so that's the point where x is minus 1 and y is 0. Then moving on, when x is 0, y is 1. So when x is 0 there, okay, y is 1 there. So that's the point. Okay, here x is 0 and y is 1. So next we have 1 and 2. So we go 1 here, go up until we reach y equals to 2, and x is 2, y is 3. So we go 2 and all the way up to y is 3. So take a step back now. Look at the points. See, these points are here, 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 and here. So you can just about see that they follow a straight line. Okay, in fact, I can draw a line joining them. Now, as you can see, some of the points don't lie on that straight line. Now that's because I've only drawn this graph by hand, just very roughly by hand. If you plot it out carefully on graph paper, you will find that all the points will lie exactly on a straight line. So this equation gives us a straight line. Now, we call this kind of equation a linear equation. So linear means straight line. Now, and when I say this kind of equation, what do I mean? What other equation can I have that is of the same kind? So let me just give an example. I can have y equals to 2x plus 3. That's the same kind of equation. I can have 2y equals to minus x minus 4. That's also the same kind of equation. Now if you look at this, look at these three equations, you see that they are all different, got different numbers, but there's something similar. All of them has a y and all of them have an x. Now, but the important thing is that none of them have x squared or x cubed. Alright, if you have an x squared, then it's a quadratic equation. So there's no x squared, no y squared, no x cubed, no y cubed, and so on. Okay, so this type of equation is a type of equation where the power of y is just 1 and the power of x is just 1. So just x and y and maybe plus some numbers. So this is the kind of equation that is called a linear equation, and you'll find that if you make up an equation like that with just the x and y, no squares, no cubes, okay, just add them together, put them on two sides of the equal sign, And when you try to plot the graph of x against y, you will always get a straight line. So let's check that out. Okay, so I'm going to do this really quickly. Let me just change this to say 2. Y is equal to 2x plus 1. Okay, so I have to make a table. So let me make up numbers like before, -2, -1, 0, 1, 2. And if I put these numbers in there, I'll get -3, -1, 1, 3, 5. Okay, so now I am going to make a graph. 0 there, -2, -1, 1, 2. This goes from -3 to 5. So that's the x-axis, that's the y-axis. So we go 1, 2, 3, 4, 5. 1, 2, 3. So -3, -2, -1, 1, 2, 3, 4, 5. Okay, -2, -3, -2, -3 is there. -1, -1, -1, -1 is there. 0, 1 is there. 1, 3, 1, 3 there. Finally 2, 5 is there. So we do have a straight line. It's a straight line. Okay, now we are going to learn a bit more about this type of graph and this type of equation. Now, I want you to notice something. See, there is a number 1 there, okay? And this graph happens to cut the y-axis at this point 1. Now, that's not a coincidence, okay? It's because at the point where the graph goes through the y-axis, that's the point where the x is 0. So you remember how we calculated that point. It's here when we have x equal to 0, I put it into the equation and I got 1. The reason is because when I put 0 into the x, this becomes 0, okay, and I'm only left with the 1. So that means that if I just look at this equation and look at that number there, the number that does not have the x, okay, just a number, we call it the constant term because it doesn't change with x. So if I just look at this number, that number tells me where the line cuts the y-axis. Okay, so just by looking at this equation, I know where the graph cuts the y-axis, and that can be useful sometimes. So this point where the graph cuts the y-axis has a name. Let me write that down. is called the y-intercept. Y-intercept, that's the point. And we can tell what it is just by looking at the equation. We don't even have to plot the graph. Now, there is another number that I want you to look at, and that's the number 2. So we have just seen the meaning of that number 1. Now the number 2, it also has a meaning. Now, to see what that means, look at these numbers. Look at these numbers here. You see that when x goes from -2 to -1, okay, y goes from -3 to -1. Now, the numbers x there, it increases by 1 each time. Alright, so when you go from -2 to -1 to 0 to 1 to 2, each time it increases by 1. Now, if you look at the number for y, it also it doesn't increase by 1, it increases by 2. Right, so it increases by 2 from -3 to -1, that's 2. -1 to 1 goes up by 2. 1 to 3 goes up by 2, and so on. So this increase is related to that number 2. So if you look at this graph, okay, let's say I start from this point there. Now, from that point, if I move horizontally by 1 unit, okay, then I have to go up vertically by 2 units from -3 to -1 to get up to that point. So if you think of this as a slope, okay, so you have a slope there where the horizontal distance is 1 and the vertical is 2. Now, there is a way to measure the slope, measure how steep the slope is. It is a number called gradients. Now, if I have a slope like that, this number gradient, okay, is calculated by taking the vertical distance of the slope and dividing by the horizontal distance. So vertical distance divided by horizontal distance. So for example, if I have the vertical distance 2 and the horizontal distance is 1, the gradient would be 2 over 1. Okay, so that is how that is the formula for gradient. That's how it's defined. So you can see that it can tell us how steep a slope is, because if, let's say, if this slope is steeper, it goes up more quickly like that, then for the same horizontal distance, the vertical distance will be bigger. Right, and so because when it goes by 1 unit in the x, it goes up by 2 units in the y, the gradient is 2. Now, and if you remember, the 2 comes from there, because each time x increases by 1, that increase is multiplied by 2. That's why the y goes up by 2. Okay, so therefore, this number here is actually the gradient. Okay, that number there is the gradient, and this is how we can find the gradient, just by taking the vertical divided by the horizontal. Now, but there is question here to think about. The formula just say vertical divided by horizontal distance. So do I have to take the horizontal distance as 1? Can I take a different horizontal distance like that? Can I take this horizontal distance all the way to here? Horizontal distance of 4. And then take this as the vertical distance. Okay, that would be -3 to 5, that's 8. Can I use those distances? Let's try that. Vertical over horizontal. So the vertical is 8, the horizontal is 4. So I have 8 divided by 4. Okay, I have here 8 divided by 4. And 8 divided by 4 is 2. They are equal. So that means, yes, we can take any horizontal distance and the corresponding vertical distance to find the gradient. So this formula can be used for any horizontal distance. Okay, and the reason why you can do that is quite simple, because these two shapes are similar triangles. They are triangles with the same angles, with the same shape, but different sizes. And similar triangles have this property that the ratios of the sides are equal. That means that if the ratio of these two sides is 2:1, then the ratio of these two sides is also 2:1. Alright, which is true because we have 8:4 in the big triangle, and 8:4 is the same as 2:1. So that's the gradient. Okay. Now let me just summarize that what we have learned so far. If I have y equals to 2x plus 1, an equation like that, and if I plot the graph, okay, if I plot the graph looks like this, right? And because of the 1 there, we know that the graph cuts the y-axis at 1, that's the y-intercept. And we also know that the gradient is 2. Right? And the gradient means that if I go to any point in the graph, draw a horizontal line, okay, and draw a vertical line down to it, then if the lengths of these lines are A and B, then I can find the gradient by taking the vertical over the horizontal, and I will get 2. Okay, so wherever I draw this little triangle, A over B, which is the gradient, okay, vertical over horizontal, it's the right angle there, must be 2. So that's what we learned just now for this equation. So what I'm going to do next is I'm going to represent this kind of equation using algebra. Meaning, instead of the 2 and the 1 there, I'm going to write this equation as y equals to mx plus c. So in this example, M is the 2 and C is the 1. So when I say this type of equation, it means that it is a type of equation where I have x, I have y, and where the m, the symbols m and c represent some numbers like 2 and 1. Okay, so I've just represented this type of equation by symbols. Now, if I imagine drawing a graph for that, what would it look like? Right, so it will look something like that. Okay, there's some horizontal line, some slanted line. Now I don't know exactly how slanted it is, how steep is the slope, but I know that it is that sort of shape. Okay, it must be straight and it is slanted in some way. And I also know that it must cut the y-axis at that value c. Just as in this equation where I have a 1 there, this straight line cuts the y-axis at 1 given by that number there. So what this means is that if I have an equation like that, okay, where m and c is actually some numbers, they represent some numbers like 1, 2 or 10 or 20. So whatever that number is in the place of c, the graph will cut the y-axis at that number, at the number of c. Okay, so that's the c. And how about the m? It means that m must be the gradient. So let me write that down. Gradient is equal to m. So if I draw any triangle here, any right angled triangle like this, and take the vertical over the horizontal, okay, let me just make up something. So let's say I do that, and that's A and that's B. So the vertical over the horizontal, which is the gradient, it must be equal to the number there, the number where in the place of m. Okay, so we have just written this equation in a rather symbolic form or general form, as we often call it. So remember, when you see this equation, it just means that m and c represent some number and the graph would look like that. So because of this this behavior, this kind of, because this equation always gives a straight line graph, we call this equation a straight line equation or a linear equation. Okay, and we remember that m here is the gradient and c there is the y-intercept. Okay, that's how we spell it. I-N-T-E-R-C-E-P-T, the y-intercept. Okay, right, so that's the equation for a straight line. Now, so far I've looked at a very simple example like that, okay, where we have two numbers there, the 2 and the 1. What if I have negative numbers? So instead of 2, what if I have minus 2 or minus 1? What would the graph look like? And does this idea does this idea still work, that C is the y-intercept and M is the gradient? So let's check that out. Let me try something simple like y equals to 2x minus 1. So I keep the same gradient 2, I just change the intercept to minus 1 instead of the 1 just now. So I would expect that the straight line would cut the y-axis at minus 1, which is really below the origin. So let's do a really quick plotting to see if that's the case. So x, y, so let me go minus 2, minus 1, 0, 1, 2. So y would be minus 2 times 2 is minus 4, minus 4, minus 1 is minus 5. So you keep going, you get minus 3, minus 1, let's see, 1 and 3. So already you see that the answer is yes, because when x is 0, y is minus 1, and that should be the intercept. But let's plot it out really quickly. Right, minus 2, minus 1, 0, 1, 2. Okay, we go minus 5, 4, 3, 2, 1. Right. Not very easy. Minus 1, 2, 3, 4, 5. So that's minus 5, and then goes 1, 2, 3. That. Right? So that's the x, that's the y, and we go minus 2 is minus 5, minus 2 is minus 5, minus 1 is minus 3, 0 is minus 1, 1 is 1, 2 is 3. Okay, so we get a straight line that goes through minus 1. So there we have the intercept, and the gradient is the same. The gradient is equal to 2 if we actually calculate it. Okay, so that's when the intercept is 0. Now let's do something more exciting. Let's see what happens if the m is negative. So let me do this. Y is equal to minus 2x plus 1. What happens then? Okay, so let's do the table. X, Y. So minus 2, minus 1, 0, 1, 2. And y would be, so minus 2 times minus 2, that's 4, 3, no, wait. Right, that's 5, 3, 1, minus 1, minus 3. Okay, that's the table. And let's plot it. Right, so minus 1, minus 2, 1, 2, and we go 1, 2, 3, 4, 5, minus 1, minus 2, minus 3. Right. So that's the x and that's the y. Now, if I go to the first pair of numbers, minus 2, 5. Alright, minus 2, 5 is here. Minus 1, 3 is there. 0, 1 is there. 1 minus 1 is there. 2 minus 3 is there. Straight line again, cutting at 1, the y-intercept as before, but look at these two graphs. You can see the obvious difference. Okay, one graph is slanted that way. This graph is slanted this way. They slant in different directions. So now you see what happens when I have a -2 for the m. When you have a minus number, negative number in front of the x, you end up with a line that slopes in the opposite direction. Okay, so if you imagine that when x increases, okay, this line shows that the y is going up, so this is like an upward slope. So in this case, when x increases, this line goes down, y is going down, so this is like a downward slope. Okay, we call this a negative gradient. There's a minus in front of the x, so a negative gradient means a downward slope. Right, now can we still find the gradient by drawing a triangle like that? So let's try. Now this time if I have to draw a triangle, let's say I start at that point. Right, now I could do this, draw a horizontal line there and come down vertically. So if I do this, my horizontal distance is 2. Okay, that's 2. Now the vertical distance is 1, 2, 3, 4, 1, 2, 3, 4. Right, the vertical distance is 4. But because I have to come down, okay, because when I move forward in the x, I then have to come down in the y. We said that we have to take the vertical distance as a negative number, it's a -4. So then the gradient in this case would be the vertical distance divided by the horizontal distance, which is -4 divided by 2. -4 divided by 2 is -2. So let me write that down. So in this case, the gradient is equal to -4/2, which is -2. And that's that. That's the gradient. So the important thing here is that it still works. Okay? This idea that y equals to mx plus c represents a straight line where where c is the y-intercept and m is the gradient. It still works even if the m there is negative. Okay? So, but you can see that I have done something subtle. I have said that to calculate the gradient, I have to take the vertical distance as negative because it's going down. So it's like I'm giving that distance a direction. Okay, I have to make that distance negative so that I get the correct sign in the gradient. I can't just say the vertical distance is still 4, then I'll just get 4/2, which is 2. I don't get the minus sign. So the subtle bit here, okay, is that I have to be careful of the sign of that distance. And in a way, it's like an additional thing that you have to do in order to make this work. Okay. Right. Okay, now, so next I'm going to look at this straight line equation a little bit more. Now, I'm just going to try out an example using this equation. So suppose I have a question in which I'm given 2 points. Okay, I have 2 points on the graph. I know what are the x and y values, and I have to find the equation for the straight line. Okay, so one point is here, and another point is there. So let's say I have 2 points on a graph, and I want to find the equation of a line that goes through these 2 points. Okay, so let me write down, let me call this point A and point B. Now we often represent the x and y values this way. So for point A, the x value is 1 and the y value is also 1. So we would write it this way with a comma in between and a bracket around it. Okay, so that's 1, 1. It just means that x is 1, y is 1. And for the point B, I have 3 and 2. So 3, 2. So point B represents this set of numbers. X is 3, y is 2. Okay, so the question is, if I know the positions of these 2 points, or the x and y values of the 2 points, can I calculate the gradient, and can I calculate the equation, find the equation for that straight line? Okay, so remember that the formula for the equation is always y equals to mx plus c. It always looks like that, okay, that you have x and y inside, and m and c are numbers. Right? Actually, x and y also represent numbers, but m and c are numbers that are fixed, okay, for different x and y's. Okay, so how can we find an answer to this question? Now, a simple way to find the answer would be to simply substitute these numbers into the equation. So let's try that. If I have an A there, or if I start with A, then let's put the numbers 1 and 1 into the x and y. So I get 1 equals to m plus c. Right? Now B is 3 and 2. So the x is the 3, the y is the 2. So I have 2 equations like that. Now, do they look familiar? I have 2 equations, and m and c are unknowns. We don't know what m and c are, but we happen to have 2 equations like that contains m and c. So remember simultaneous equations. So this is a set of simultaneous equations, and that means we can solve them. Okay, so how do we solve this equation? So let me call this equation 1 and equation 2. Okay, the way to solve it is to look at the equation, look at the 2 equations and compare the unknowns. So I have m here and 3m here, I have c here and I have c here. So the idea is to pick out one of the unknowns, like m, and look at the number that multiplies the m. Okay, here we have just m, here we have 3m. So the idea is that you want to multiply this first equation by 3 to make the m, the term in m, same as the term in 3m. Okay, in other words, you want to make the two unknown terms same. But in this case, we don't have to do that for m because we already have c and c. We already have two terms same, right? The terms in c. So what we can do is, if we have two terms the same, then the way is to subtract the two equations. Okay, remember how we subtract equation. Now, let's say I want to subtract 1 from 2. So I want to do 2 minus 1. So I would have to subtract the left hand side by the left hand side and the right hand side by the right hand side. So I do 2 minus 1. Let me write the equal there. On the left side I do 2 minus 1, I get 1. On the right side I do 3m minus m, which is 2m, c minus c, which is 0. So that's all I get. Now 1 equals to 2m is what we get. So we can solve this quite easily. Okay, you can even guess that m must be half because 2 times half is 1. So we have the answer for m. M is half. And if you know that m is half, we can substitute this into one of the equations to find c. So for example, if m is half, imagine putting it into there. If m is half, half plus c is 1. What is c? Half plus c is 1, so c must be half, because half plus half is 1. So therefore c is also half. So there we have m and c. We have m and c, and we have our equation. So the equation is actually, let me write it here. The equation for this straight line going through the 2 points is in fact y is equal to mx plus c, where m is half and c is half. So it's equal to y equals to half x plus half. So that's how we get an equation for straight line going through 2 points that we know. We shall stop here for this session. Thank you.